Okay, looking at 8.1, number 39. I could have chosen a simpler problem, but I thought I would get a little deeper into this. We got to deal with the powers, and the way I like to explain it is this power sort of gets distributed to each element inside here. And the same thing's going to happen here, of course. So we end up with 3 squared x squared and 7 squared x to the 8th. Because you remember when we deal with powers, you multiply them. When you deal with them in this regard, you multiply them. And I guess it's noteworthy to say that the 3, just the plain old number 3, actually has an understood 1. And so that's why 2 times 1, it would end up being 3 squared. I'm just saying that to reinforce that you're actually multiplying. 2 times 1, you're not just giving it to the 7. There's an understood 1 there that you multiply times. So now that we don't have a power here or there, we actually don't need the parentheses. And everything is really being multiplied. I think my students are probably pretty comfortable with that idea that when you have something like, let's say we just have this 3x squared, they know that it's 3 times x squared. So in this case we've got a whole string of elements being multiplied times each other, and these can be grouped because they have the same base. They have the same base, which is the x part. And when we put these two together in this way, we actually add the exponents. In a simpler problem, I probably would show that x squared is really x times x, and x to the 8th is x, 2, 3, 4, 5, 6, 7, 8, 2, 1, 2, 3, 4, 5, 6, 7, 8. So this one actually came from there, and all these multiplied together would end up being x to the 10th. And so that's what these two, I'm just breaking this out to sort of prove to you, if it helps you, that when you do multiply these two, you add the exponents. How do they end up being x to the 10th? If you break them apart, you can see there's 2 here, and then there's 8 there. And interestingly enough, every one of these has an exponent of 1, an understood, and as you multiply them together, you end up adding that 1. 1 plus 1 is 2, 2 plus 1 is 3, 4, 5, 6, 7, 8, 9, 10. So that's how we end up there. I don't need to see that kind of breakdown when you're working through your problem. I just want to see this turn into x to the 10th, and that's correct. So actually, I'm going to write the x to the 10th off to the right, so I can bring this 7 squared over here. And 7 squared is really 49. 3 squared is really 9. 9 times 49, what's that, 441 or something?
Kirk Bowman, please come to the office. Kirk Bowman, to the office, please.
It's a negative 441, x to the 10th is the answer. And so that is how you do this problem. And you use this method and a lot of the things I described in it throughout 8.1. So seeing this problem should help you get a lot of those other problems done.